This is trig functions part 4. We're going to graph the cosine curve, which will be pretty similar to the last video. So if you are all set with that, I think you can skip this video. We're going to start by reviewing the unit circle, graph a cosine curve, and then look at its domain and range. So from trig functions part 2, we saw that the unit circle is centered at 0, 0. It has a radius of 1, which means that if I connect out to any of these points along the outside, say that this is some angle theta, and I drop this down here to create a right triangle, my hypotenuse has to be 1 because that's what the radius is. My base length I'll call x, and my height I'll call y, because those lengths describe the coordinate point that I connected to, xy. And if I set up some right triangle trig expressions or equations, I would have the sine of theta equals opposite over hypotenuse, so that's y over 1. And the cosine of theta equals adjacent over hypotenuse, so that's x over 1. So we figure out that this coordinate point xy can be described as cosine of theta, sine of theta, for some angle of rotation in the middle of that unit circle. We're looking to graph the cosine curve today, so we're going to be paying attention to the length of the base of the triangle created when we go to any given point. Remember that we use the first quadrant. So the first quadrant is that top right as all of our reference angles, because both sine and cosine are positive in the first quadrant. As we go around to quadrants 2, 3, and 4, sine or cosine might become negative, depending on whether they're below the x-axis for sine or to the left of the y-axis for cosine. So when we look at theta equals 0, we're on that one-dimensional flat line there, and the length of that base, because remember that's what we're interested in, the x value, is 1. So we can graph that right up here. I should first define my x and y variables on this graph here. So the x-axis is describing my angle of rotation, my theta, and the y-axis is describing the length of the base of the triangle. Okay, so when theta equals 0, the length of my x, my base, is 1. And when theta equals pi over 12, I've got that right triangle there. So what I'm just going to do is I'm going to turn that right triangle to 90-degree rotation clockwise, and then the base of the triangle, which was here, is now up here, and I can just graph it kind of the same way I did with the sine curve. So when pi equals 12, I've got that base. When pi equals 6, I've got that triangle rotated, gives me that base. And so I can do this for a little while. Okay, notice when I'm looking at pi equals 2 pi over 3, my base is actually shorter than my height. So when I rotated that triangle 90 degrees clockwise, my base became shorter. And so I've got that point there, and we can do this on and on. Let's look at the x-intercepts, pi over 2 and 3 pi over 2. So based on this graph, this is telling us that at pi over 2 and 3 pi over 2 radians, the length of the base is 0. Remember that pi over 2 radians is 90 degrees, and so if I'm looking at that triangle, which in fact is just a straight line going straight up, the base of that triangle would be 0. So that makes sense. And likewise, 3 pi over 2 is down at the bottom of our unit circle. Okay, looking at 2 pi, I'm back to where I started, which is a base of 1, and at pi, I'm at 180 degrees, which has a base length of negative 1 because I'm to the left of the y-axis. I'm on an x value that's negative. So the domain is the set of all inputs that map to an output. Range is the set of all outputs that map to an input, or get mapped to by an input, I should say. So looking at the domain of the cosine curve, that's saying what are all of the theta values that we can use. So we usually start at 0 and we rotate around to the right. And we usually stop at a full rotation, which is 2 pi, but I can just keep going around and around and around, and this pattern will just keep happening again and again. Okay, so we'll have that wave, the same shape that we saw with the sine curve, but the sine curve started at 0 and went up before it came down. So this is a sine curve that's been shifted to the left by pi over 2 radians. So we can see that the domain is all real numbers. Any angle of rotation works, even negative angles of rotation, which go clockwise instead of counterclockwise. And the range is going to oscillate between -1 and +1, just like the sine curve did. So -1 is less than or equal to y, which is less than or equal to 1. We'll talk about transforming sine and cosine graphs in part 6, and part 5 we'll graph the tangent function. So be sure to check those out and do the practice problems.